really important because that's basically the registration for the final assessment. So I can see the names of who have registered and everything. Okay. So if you have some friends who have not yet joined and have not joined through today's lecture, you make sure that they join. Inform them that this is going to happen. Okay, so let's move on. So today's lecture is a continuation of yesterday. So yesterday we saw, I mean, we had an intro to renewable energy. We had solar PV, thermal, and wind, and a little bit of energy statistics. So we'll be seeing a little bit more on the energy statistics front and the sustainability perspective of energy. Okay. So, so yeah, what is sustainability? We'll have a recap on that. The primary energy in India, the energy system transitions, the UNDP Energy Plus program, and then there'll be an overview on the Indian electricity system. And we have seen particularly the urban sustainability index in the first lecture. There'll be something similar here. So there will be a sustainability assessment of the Indian electricity system. A case study will be presented in this. And then a recap of the representative concentration pathways and strategies for net zero emissions target. And then, yeah, there'll be energy for social development, which is, yeah, similar to the UNDP. That's what we'll be seeing. And there'll be a small discussion on biomass as a sustainable resource. Then we will go on to the Q&A. So what is sustainability? I don't have to teach you again. Can you just let me know? I mean, someone just tell me. Anyone? Just
Sir, sustainability is using the resources while considering the needs of
yeah,
all the stakeholders and
yeah. Who
not
are the stakeholders?
the environment, society, and the
Hmm.
future generation also.
Yeah.
And yes.
Okay. So when we talk about society, there is also another perspective here. That is the economics that also comes into play here. So because like okay, so if you have to move to a greener option, okay, for example, like okay, right now it's not relevant, but 15 years ago, as I was mentioning, the solar electricity was 17 rupees per kilowatt hour per unit, whereas the grid electricity was available at what 3-4 rupees, right? So at that time, if you had told someone that, okay, we have to go green, we have to save the environment, so you have to purchase electricity at 17 rupees, would he have listened? Or forget people, even companies, they wouldn't have done it because that's affecting their profit at the end of the day. So that's also important. The economics is also very important, and environment, society, and society also includes intergenerational justice. So we don't indiscriminately use up all the resources, so we save some for the future, right? And so coming to the primary energy consumption in India, production, this one is in picojoules. Right. So from 1990 until you see until 2020, it's been increasing. And but if you see, most of this increase has been through, um, coal, right? So you can see at the bottom, this is coal. Okay. And there is a slight decrease in 2020. Can someone say why there is a decrease? So it's been increasing since 1990, right? The primary energy production. It's been steadily increasing, but there is a slight decrease as we approach 2020. Anyone?
Is it because of COVID, sir?
Yes, absolutely. So because of
Yeah.
COVID, I mean, there was not much consumption at all. So even the production had dropped during the 2 years, 1 or 2 years after COVID kicked in, basically, right? So, but coal is the most predominant here, okay? And you can see even the crude, natural gas, and other feedstocks, and sorry, not natural gas, crude and other feedstocks, and natural gas, it's quite less actually. and nuclear it's negligible. Renewables actually it's why okay let me ask you this question. So you can see that even in 1990 the renewables you can see quite quite a huge chunk of renewables here. Why is it so? When I just said that we started our solar mission in 2010, and wind was started only in a few states, like Tamil Nadu had a good wind portfolio already by 2010. Okay. So can someone tell me why this is? And this is not just electricity, this is energy. So remember that and give me an answer for this. So what kind of renewable it could be, and what was it used for, or it is still being used for that purpose? And let me also tell you this, this may not necessarily be a positive thing. Okay. It's not a positive thing at all. So
So using firewood for cooking,
absolutely,
firewood for
yes.
many
Yes.
stuff.
Yes, absolutely. So that is
Yes.
biomass, right? Firewood is biomass.
Yes.
Not
Yes.
just firewood, they even use cowden cakes and other residues that, rice straw and stuff. So they use that for cooking. The issue with that is, I mean, it's not using it is not an issue as such. Okay. But in the form they use it in, because the cook stoves are very inefficient and then they're open, right? But
Yes.
there's no proper ventilation in the kitchen in the
Yes.
villages. If you see, there's no proper ventilation. So what happens is there's a lot of
Carbon
indoor air
monoxide.
pollution, there's carbon monoxide, there's PM 2.5, PM 10, all of these emissions that then causes a lot of health effects, right? So
Yes.
in this regard, actually, our center did an innovation about, I think, 20 years back. There was, more efficient cook stoves with that reduce the indoor air emissions, basically. So that, in fact, if you can make it to Bangalore in around Feb March, we have this open day in IISc, so you can come to CGPL, that is our lab. Okay, you can see this cook stove being displayed there. In case any of you, you can just keep it in mind in case you're around during that time, right? Okay. So the previous one was the production. Now this is consumption. So consumption is again, it's a similar picture, right? So you have coal. The coal has been increasing, right? When it comes to consumption, but uh, oil products are quite high in terms of consumption. Why? Because of automobiles, and there are many industries that use oil. Like for example, plastics. You produce plastics are made of oil, right? So, and in a similar fashion, you can see renewables and waste also, and this denotes the same thing actually. And if you see after 2010, there is a slight increase in the renewables, right? So if you see the width of this green bar over here, right? It's almost the same until 2010, because we are considering only biomass until then for cooking. After this, it has been increasing. The width has increased, if you can see here. And that is because of all the installed renewables and the renewable generation, basically, right? Yeah. So, like I said, the primary energy categorized as renewables and waste is comprised of firewood, right? And it's not necessarily a very good thing. So, coming to the Indian electricity system, so we saw this yesterday, right? So about 51% of the installed capacity is thermal. I mean, sorry. So you have much more than that if you consider all fossil fuels. So it's close to 60% and about 40% renewables. But then the generation is not exactly in line with the installed capacity. And why is that? Why
Factors
is that?
like maintenance and capacity utilization factor.
Yeah, maintenance is not, I mean, maintenance is something that you decide. Okay. So capacity utilization, that affects the capacity utilization factor, of course, but then this is something that you cannot influence. Okay, the CUF is not something that you can influence easily, especially when it comes to solar and wind and yeah, basically renewables. Okay, but coal or gas or diesel power plants, all of these, if you want, you can run it for 100% of the time during the year. But then you choose not to because, of course, you don't want it to shut down completely. So you have to do maintenance, overhaul, and all that. Okay, so that CUF is forced kind of. So this is natural, the solar and wind thing. So you can't really influence that. Okay,
do
so
anything
because of
about it.
this, yeah, so because of this capacity utilization factor, so we have 80% of our electricity generated by thermal energy, coal, natural gas, and diesel thermal. It's all together put together, and then you have very little especially when it comes to renewables, it's only about 10%, like solar and wind. I mean, despite having what close to 100 gigawatt of installed capacity. So why do we need renewables? So this is another thing that we have already seen. So I think someone can let me know what this graph indicates and what are the consequences. So we just saw this yesterday. So it's just a recap of yesterday.
So yesterday we talked about RCP 8.5 and RCP 2.6. And
Right.
if we continue the rate of consumption as we are doing now,
Hmm.
this will be the RCP 8.5, and we
Yeah.
are trying
So
to come
what
to
is that
RCP
number?
2.6.
What does that number denote?
The RCP 8.5.
Yeah, the number after RCP. What does that 2.6, 4.5, 8.5, all of these things.
No, no, sir.
Okay. So this number is basically, it's called radiative forcing. So basically, we talk about global warming, right? So what is meant by global warming? So it means that some heating is happening, right? Okay. So it's basically whatever the heat from the sun, whatever is coming, is trapped within the atmosphere. So that's what the greenhouse gases are doing basically. Like the more the concentration of greenhouse gases are is then what happens is all the heat gets trapped. How much of that heat is trapped within the atmosphere? So that's what this number denotes, and it's measured in watt per meter squared. Okay, so what is the unit used for heat? So per meter squared is per meter squared of Earth's surface, basically, right? Right. So here 8.5 means 8.5 watt per meter squared of radiation is being trapped within the atmosphere. So this is called radiative forcing. Okay. So you can continue now. You can.
Okay, sir.
Yeah.
So our goal, in order to reduce the consumption absorption from 8.5 to 2.6, we have to
Yeah.
utilize biomass,
Hmm.
which
So
is
it doesn't have to
in
be
the
just
second.
biomass. Yeah.
Yes,
So you're
a large
basically right,
percentage is
but
contributed by biomass.
yeah, yeah. So that is the maximum contribution from bioenergy. Okay. So in whatever form. Okay. It could be in terms of fuels, biofuels. It could be electricity. It could be something else. Okay. But yeah, bioenergy has a huge contribution, and we have to reduce the quantity of coal in our energy mix. We cannot completely do away with coal, as I already told you yesterday. And why is that?
What's it?
Why can we not do away with coal completely?
Because it provides the threshold energy, like the
Yes.
constant supply of energy.
So what is it called in terms of load?
The minimum load, the
Yeah,
payload,
it's called, it's base load.
base
Okay.
load. Okay. Yes, sir.
Yeah.
Yes, sir.
So there is base load and there is peak load. Base load is like the stable quantity of supply that you need. Okay. Let's assume you have base load of, I mean, the minimum, absolute minimum consumption in any region, or it could be your house, or it could be a city, or whatever it is. So this is the absolute minimum that you have to supply. Okay. If you go below that, then you're not getting supply at all. Like completely zero supply you'll get, because your absolute minimum consumption is that much. So let's assume there's 20 megawatt consumption, then you'll have to provide 20 megawatt at all times. Okay, if 20 megawatt is the minimum consumption, that is. Okay, and that kind of base load, for that base load, you need something very stable, a very stable source of energy, and coal can provide that, because there is coal is in constant supply. I mean, there is no dearth of supply, at least for now. Okay, and they can stack up even if there is some transport strike or whatever it is. They can stack up for months on end. So no, so the question here is coal alone contributing for the base load? The answer is no. You could have other sources as well, but it has to be stable. So if you had attended the class yesterday, you will know that during the question that there was a question about solar thermal well storage. So that's right. That's another base load source of energy that can be used. Okay. And there is also, you could also use diesel actually. I mean, it is stable. It is, but it can be flexible also. It can be stable. So diesel can be used for both base load as well as peak load. Okay. So anything that has a stable supply, basically that can be used for base load. Okay. Yeah, so for RCP 2.6, you have a healthy mix of bioenergy with coal, and there is no indiscriminate amount of using coal, like in this case, in the case of RCP 8.5. Okay, so this is more preferable, because if we go if you go on this on the same pathway with RCP 8.5 using a lot of coal, then we'll reach about 4 to 5 degrees of a temperature rise. Okay, from the time of industrial revolution, right? So if that happens, then the consequences are dire. I mean, there will be huge climate catastrophes. We can already see this happening in India. I mean, you can see this. Uh, I mean, there are floods in many states. In fact, not just one or two states. Yesterday, I told you the example of Wayanad. If you see today, there have been there have been some news articles coming out from Telangana, Andhra Pradesh, Gujarat, all of these states. And in fact, even in northeast Bangladesh, there was flooding a few days ago, right? So all this news came out. So this is all a result of climate change, right? So we need to ensure that the temperature rise is limited to 1.5 degrees, less than 2 degrees, basically, to ensure that okay, at least we'll be stable. So the consequences, I just mentioned this in passing. So a few years ago, Maldives wanted to buy land in India to, uh, you know, uh, relocate their people here when their highlands go underwater. Okay. And it is estimated that there will be at least 100 crore, 1 billion refugees, climate refugees by 2050. So that's scary, right? So we already have all these wars going on, and there's a refugees crisis, in the Middle East, in Europe, and elsewhere. And add to that 1 billion more refugees, I mean, refugees of climate change, basically, that's going to be a huge catastrophe. So this is just a strategy given by IEA a couple of years ago as to how we can achieve net zero emissions. So So one of that is nearly 50% of the electricity from low emission sources. So it's not um, installed capacity, but it's generation of electricity from low emission sources. So that's very important to note, right? Then no new sales of fossil fuel boilers. Then you have 8% of emissions from yeah, so there is one more very important technology that has come up up and coming right now, that is carbon capture and storage. Okay, so the emissions from cement industry can be captured and stored. I don't know how sustainable that will be in the long run, because you need to find deep underground aquifers. So geotech, geologically, it has to be the storage sites have to be chosen. Okay, so whether those are available naturally or can you actually make it? So I'm not an expert in this field, but there are lots of questions on this. But this is an up and coming technology. And yeah, so there are, so by 2035, there should be no new IC engine car sales. But then here they mean from IC engine, you go to electrical or EVs basically. Okay, so the issue with EVs is, okay, if you have renewable energy, sufficient portfolio of renewable energy, like over here, 50% of the electricity, then it's okay. But then in the current scenario, it is not exactly advisable to go for EV, because 80% of our electricity comes from thermal power. There is fossil fuels, right? So first we have to ensure that all our electricity comes from renewables, then we have to go for EVs. Okay. And having so many new EVs will cause issues with respect to grid stability as well. So we need to consider that. Okay. And yeah, so we are basically replacing the fossil fuels with electricity. That's again, it's a double-edged sword. So that's something we need to consider. Okay. And retrofitted buildings, zero carbon buildings, basically. And then, so at the end, you can, I mean, by 2050, this is a plan, like, okay, that by 2050, we can go into net zero. But I'd like your opinion on whether this will work, whether this is something that could work, or is it practical, or do you find some discrepancies in this? Yeah. Anyone? Any
Yes,
opinion
sir.
on this? Yeah.
Sir, because of lithium ion,
Right. What about lithium ion?
it is mined because it's very costly, right, sir?
Yeah. So that's another good point actually regarding EVs. So lithium is very rare actually. It's not very abundantly available. So it's only 5 or 6 countries that have a substantial amount of lithium. And so if you go for EVs, you need to mine all the lithium, and then so especially in India, okay, we have some deposits of lithium, but not so much. We need to depend on mostly China, and then some South American countries, actually, Bolivia and I think Peru for to some extent. And the issue is basically, if you are replacing fossil fuel as in IC engines with EVs, then you're just replacing the Middle East with China. That's the only thing you're doing in terms of import. Okay, but this is not in terms of environment itself. Let's talk about net zero emissions here. So this is more in terms of the economics of it, macroeconomics, about imports and stuff. And so can we talk about, in the perspective of net zero emissions, what you feel about this strategy?
What's it? What is it that you said at the end?
Mhm.
What did you say at the last?
No, I just want 1 second. Yeah, I was just saying. Um, I was just saying that. See, I just want an opinion on this, like on this entire chart, right? The strategy to achieve net zero emissions. Okay,
Yes.
so you can have a look at this chart. And then you can give your opinion on whether this is feasible, or and do you have some reservations about this strategy?
So there's politics involved here.
No, I just talk in terms of the technological aspects, and you know,
Yes, sir.
I just want to know whether this, according to you, if this is feasible to achieve net zero emissions. That's it, nothing else. So you look at all of these strategies. So how far is that feasible? Like for example, they want to have like 670 gigawatt of electrolyzer. So electrolyzer is basically splitting of water to form hydrogen and oxygen. So the hydrogen can be used for energy purposes. Okay. So in my opinion, that can be a little tricky, because where will the water come from? If you say that you're taking it from the ocean, that's well and good, but you cannot really use salt water from the ocean for electrolyzer, right? So you need
Then
fresh
you'd
water
have to do
sources.
reverse osmosis again on that water
Yeah,
if you're
yeah,
using
exactly.
ocean
So you're
water.
just depleting water again. I mean, that's you're solving one problem and creating another. So that way,
Yes.
so
Yes.
take any one point out of this, and then you can give your opinion on it.
And even the electrolyzer thing is also
Mhm.
it's expensive, like solar was when it was at in the beginning,
Yeah,
right?
yeah, it is expensive. Yes,
It's very
absolutely.
expensive actually.
Yeah,
And
yeah. So that's one point. Yeah. Anything else?
So
So yeah, go
yeah,
ahead.
for replacing the IC heavy trucks, they would
Mhm.
require a lot of like energy for this pulling power and all. So how is that practically possible? It will take up more
So
energy. You have to have frequent stops for like refueling, like for recharging.
yeah, that could be possible, but you can achieve that through a bigger battery bank or something like that. If it is EV, there are also hydrogen trucks. The hydrogen is feasible. So, but then the issue with hydrogen for transportation is that you need to store it at 350 bar or 700 bar pressure. So, which is basically a ticking time bomb right above your head. Although you have all these composite materials that do just fine in this day and age, it's still, I mean, I'm a little apprehensive about that, about this 350 bar tank stored above my head. Okay. So, okay, let's say even if that is feasible, the production of hydrogen itself is going to be such a huge task. Okay. So your point about IC trucks, heavy trucks being replaced by something else it seems a little far-fetched as of now. It could be done in pockets. So whatever these strategies say, right, they could be done in moderation in some pockets. It cannot. The scalability is the issue, and that's why we achieving net zero, or achieving net zero could be possible in some future time, in some indefinite time. But then, uh, having a specific timeline for that is going to be incredibly hard, because there are so many things to consider. There are technological aspects. There are there are economical aspects, there are political aspects, there are so many things, right? Okay, moving on. So we'll come to this case study on Indian electricity system. So this case study was done by by Tarun Sharma and Balchandra. I told you about him, Dr. Balchandra Patel. He's a professor at the Department of Management Sciences, and Tarun Sharma was a student. So in 2015, they came up with this study on how to benchmark the Indian electricity system in terms of sustainability. So they took a total of 119 indicators, out of which 29 were social indicators, 46 economic, and 25 environmental indicators. And they had the center institutional, that is the governance parameters also. Okay, and the normalization. So can someone tell me what normalization is?
So the actual value minus the minimum threshold divided by max and minus minimum.
Yes. Why is it done? Why is normalization done?
In order to get where that particular city or location is when compared to the others in a list.
So I mean, no, it's not about comparing cities or something like that. It's more of comparing different types of indicators which have different units. So it's so that it's not apples to oranges comparison. It's basically saying that apple is also a fruit, orange is also a fruit. Now it becomes easy to compare, right? It's that way.
Yes. Yes.
So in reality, you cannot compare an apple to an orange, but when you say that both are fruits, yeah, now it's like, okay, let's compare the qualities of these fruits. It's that way. Okay. So you make them dimensionless so that it becomes easy to compare. So let's say climate change versus education. So can you compare them? No. So you ensure that they are both on the same page through normalization. Then you can compare both. So that way. So the methodology was followed. It was the same methodology as you saw for the urban sustainability index. So where you have the dimensions, then you have the themes, sub-themes, and then you have the composite indicators and indicators. And the normalization we just spoke about. And so once you have the normalized indicators, you have to aggregate them through either arithmetic mean or geometric mean or root mean squared. So these are just methods of aggregation. I'm not going into that. Okay. So if you see here, there are these three dimensions, right? So social, economic, and environmental. So before that, let me ask you: can you give one example of all these three dimensions in the Indian electricity system? So in the perspective of Indian electricity system, I just need to know one indicator in each of these three dimensions. Well, let's start with the economic dimension. Any one indicator.
The cost of like electricity or something.
Yep, absolutely. Cost of electricity. That's one. Can you tell me one on environmental indicator?
The carbon emission or something when you use coal. Or
Sure, but that could be like a composite indicator. So you can break down the carbon emissions also, right? What causes the carbon emissions in the first place?
you use coal and
Yeah. So what can be a measure like in terms of an indicator, measurable indicator?
carbon footprint or greenhouse gases and something.
No. I mean, that's what global warming is, right? Climate change is. So I'm asking you, I mean, you break it down. You just told rightly that the amount of coal that we use that causes carbon emissions, right? So convert
Yeah.
that, whatever you said, into a measurable indicator.
The
Just
consumption of coal by a certain industry.
No, it doesn't have to be an industry. We are talking about the entire Indian electricity system.
So the amount of electricity generated using coal.
Yes, that's true. It doesn't have to be just coal. You can make it like the share of fossil fuels in the Indian electricity system. And what will be the unit for this?
Gigawatt? No.
Mm, it's a share, right?
Yes, like 60%.
Yeah, percentage is the
Yes,
indicator for
percentage.
this,
Yes.
right?
Yes.
So that is one. And okay, let's come to the social dimension. So what could be an indicator here in the social dimension?
the
The amount
accessibility
of
as
electricity consumed by
So
a particular area or locality.
no. I mean that's
No.
you're right there, but there's another answer, right?
if everyone is like able to access it.
Yes, accessibility. So that's very important. Energy access is one of the most important indicators when it comes to social dimension, right? So if you see here, you have accessibility, affordability, adequacy, and uh, productivity, acceptability. So these are themes actually, but these can be used as indicators also. You can break it down and then you can measure the accessibility and all that. Okay. So in economic, you have all these themes. So production, supply, end use, cost, and security. Okay, so like energy security is one very important indicator. So how many years can you actually sustain this energy supply, right? So similarly, you have the supply of energy supply itself, and then you can break it down to different composite indicators and indicators, and that way, right? Then you have an environmental, you have atmosphere and environmental transition. They have taken here, where climate change, air quality, low carbon transition, and zero carbon transition are some of the sub themes. So they have composite indicators and indicators also. So the overall sustainability of the Indian electricity system, this is as measured, I think, in 2013. The paper came out in 2015, but this study was done in 2013. So it's 0.377, which is not a great number, right? As per this framework. So these are some of the dimensions, right? You can have a look here. See average tariff, right? Yeah. So the cost of electricity could be an economic dimension also will come under economics also, but then it's the people that are spending for the electricity, right? So that's why it's under the social dimension here. Okay. So urban household electricity access. So we spoke about the energy access. So that's very important. And percentage of villages electrified. So if you come to economic dimensions, you have the share of renewable capacity, share of renewable generation, all of these things. Okay, what else do we have here? Yeah, thermal efficiency of the coal power plants. So this is very important, right? And you can see the tariff over here also. So it's a repeated indicator. Okay. And similarly, you have in the environmental dimension, you have the share of electricity from natural gas. And you can also have, coal-based electricity and renewable sources, all of these, and CO2 intensity of electricity generation. This is in kilogram per kilowatt hour. So in India, it's about 127 gram per kilowatt hour. That's the CO2 intensity of Indian electricity system as of 2023. Okay. So then they did a future analysis kind of, and where they considered four scenarios. One is heroic effort, aggressive effort with abundant nuclear. Sorry, I think three scenarios. Yeah, aggressive effort with gas. Okay, so you need to have natural gas or nuclear or whatever it is. I mean, to supplement the need for base load, peak load, all of these things. Okay, so you can't go 100% renewable. That is the basic argument that they are going with. And in each scenario, they have measured all these indicators that I just showed you in the previous slide, and they have come up with a new sustainability score. Okay, so they can be improved by 27 to 35%. That much can be the improvement based on the different scenarios from the baseline. Okay, so you can increase it to up to 0.51 from 0.377. It can go up to 0.51, and that is with aggressive effort with nuclear, wind, and solar. So you need to increase the capacity of wind and solar in the mix, and you also increase the nuclear power in the mix. So nuclear power is non-polluting, so it does not cause any pollution or global warming. The only issue with nuclear is the disposal of the radioactive waste, but there are there are procedures for it, and it's quite very robust actually. So yeah, nuclear is a very good option actually. So coming to energy for social development, we spoke about energy access, right? So the transition from a social perspective can have substantial opportunities and challenges. So on the supply side, you have the opportunity is that the grid infrastructure has almost reached everywhere in India. So a few years earlier, the government claimed that all the villages in India are electrified. Okay, the definition of electrification of a village is that 10% of all households in that village should be electrified. Or should have an electricity connection. It doesn't have to be the supply part of it. If you have a connection, it's counted that you are electrified. Okay, so 10% of the households should have an electricity connection and a community hall or something like that, some public space, right? So that is the definition we have. So it's not that we have electrified every household in every villages. Only 10% of the households are electrified so far. Okay, but yeah, the infrastructure is there. So we have the infrastructure. The challenge is the reliable and continuous flow of electricity. This is obvious actually. And on the demand side, you have in the opportunity is that you have need-based and lifestyle electricity consumption in almost in most of the villages. Right. So what is need-based consumption and lifestyle consumption? So need-based is you have lighting, you have cooking connections, all of these things. Okay, so this is not just electricity. This is just basically energy. So even cooking comes under energy, right? Lifestyle consumption, as you have TVs and mobile phones, all of these things. The challenge is the electricity consumption for social services, like you have your community centers, which public spaces like schools, clinics, and then productive use. Productive use is when you use electricity or energy for productive purposes, for creating jobs and income generation, basically, like cottage industries, MSMEs, and so on. So the UNDP Energy Plus program. So there are three stages to this program. The first stage is you have connections. Okay. So what do you mean by connections for all? So recently we had this Ujjwala. How many of you are aware about this Ujjwala scheme of the government of India? Do you know what that scheme is?
Part
Yeah.
of it, sir, is not clear.
Sir, I don't know about Ujjwala, but I know about that Bhagya Jyoti, where government is giving a certain amount of free electricity. It's a complete electricity, a certain volts for this house. I think they should not pay such amount and stuff like that for the lifetime.
You
I've
mean the
heard.
government of Karnataka, is it?
Yes, sir. Sir,
200 units
yeah,
free, that one.
yes, sir. 200 units. Yes, actually.
Yeah,
So
so
not recent one, sir. Recent one, yeah. Recent one they have given some amount, but the previous one I'm taking, but I'm just telling where certain amount of current is free for the lifetime. Yeah,
okay, okay.
in our area that is there. So that is called Bhagya Jyoti something and all. Not
Okay,
Ujjwala.
that could be that. See, government normally gives free electricity for irrigation. Okay, for the farmers, they give, I think, 6 or 7 hours of free electricity every day. Okay, so that's completely free. They don't have to pay for it and all that. But here we are talking only about connection. So there is a difference between connection and adoption. So here, Ujjwala scheme is when you remember a few years earlier when the government asked us all to voluntarily give up our subsidies so that the government can focus on the lowest, income groups, where they gave free LPG connections to these rural areas. Do you remember this? So free LPG connections were provided to rural areas where they were still
Yes.
using traditional fuel like firewood and all that.
Yes, sir.
Okay. Yeah. But the issue with that scheme was that it was only the connection that they had given. Okay. So if you use up a cylinder, you have to purchase a new cylinder, right? You have to replace the cylinder. The refueling cost was very expensive, so that kind of killed the entire idea. So uh, there's a guy called Rahul Narlanka, who recently completed his PhD in IISc, and he is a professor at Manipal actually. So he has written an article. So you can just search his name, you'll get that article. It's a beautiful article on why the Ujjwala scheme and all of these schemes basically failed, or or what more should be done so that they can succeed in the future. So you can have a look at this. So there's a difference between connection and adoption. So connection is just you're just giving someone something. Okay. So what about the second and third and subsequent installments? They have to do it themselves. Okay, it's that way. Okay, but that is the first step. Okay, so you where there exists no connection, you have to start the connection first, right? So if there is no electricity in a village, you build the infrastructure and you give the electricity the first installment at least for free, right? So that's the first step. Then the second step is energy for all. Okay, so you have the connections now, you have the infrastructure now. Now you provide the energy for all. So there are three types of energy. One is basic, lifestyle, and social energy services. And so basic is, like I said, lighting, cooking, all of these things. Lifestyle is, mobile phone charging and televisions, radio, all of these things. Social energy services is if you provide electricity for schools, colleges, and hospitals, clinics, uh, maybe panchayat office and all that. Okay. And then the third level of this is when you transition from basic, just an energy kind of consumption for lifestyle and basic and lifestyle energy consumption to aspirational energy consumption. That is, you are actually generating something. So energy plus empowerment. So you have your own industry, or maybe you're running a shop from your own home or something like that. Okay, for which you're using energy. So that is productive energy consumption. So in fact, even the electricity for irrigation should come under productive energy consumption. Okay. So energy plus basically refers to this energy plus empowerment, where you have productive energy services. Okay. So yeah, energy plus access is provided to reduce poverty. So you have clean and reliable energy access to all of these schools, industries, and public spaces. Okay, and that leads to a lot of positive things like improved literacy rates, lower infant and maternal mortality because of clean energy access to hospitals, reduced indoor air pollution. So we were just talking about this a few slides earlier, right? And more agricultural productivity and higher productivity due to better working hours. So if you have um, lighting for maybe 3 or 4 hours in the evening time, then they can be more productive. Okay, and enhance security, of course. So there are some definitions. So energy access. What is energy access? It's just the reliable and affordable access to modern energy carriers. So the energy should be affordable. It should be reliable. There should be energy security, and they should be able to access this energy. Right? Energy poverty is just the lack of energy access. Right? Then you have clean and improved cooking stoves that is self-explanatory. So domestic or industrial stoves designed to reduce indoor air pollution. And energy service company, it's any enterprise that provides some form of an access to energy and associated end-use services. Like for example, it could be a discom, Bescom, Mescom, all of these. They're all energy service companies. Okay. And productive use of energy to create goods and services, jobs, and so on. Okay, so we'll just do a small discussion on biomass as a sustainable resource. So how sustainable is or how economically feasible will is a transition to a bio-based economy. Okay. So biomass can be converted into useful forms of energy and other products, such as biofuels, power, other chemicals, and all. Okay. So how sustainable is biomass really? That's the real question. And then can biomass produce lower emissions than conventional energy sources? And can biomass in its modern avatar successfully penetrate and enhance livelihood of the rural populace? Okay. And how economically feasible is this transition? So can we discuss? Let's um, let's start from here. Like how sustainable is biomass in reality?
Just like how coal is found on Earth, biomass is also obtained from Earth only, and both have carbon emissions. Correct, sir?
Yeah, but then biomass is considered carbon neutral. Do you know why that is?
Because the residue generated after extracting biofuel from biomass is then you put back into the soil for organic.
No, the residue is not put back into the soil. So you take the residue from the plant or from the crop, basically. And then what you do is you convert that residue into whatever you want, electricity or some chemical or biofuel or whatever it is you want. In the process, you are emitting some carbon dioxide. Okay. Is it related to circular economy? I'll just come back to that. Okay. So in the process, you're emitting carbon dioxide. But then where did this biomass come from? So it is from the growth of the plant. So what does a plant do?
Yeah, plant captures the atmospheric carbon dioxide and
absolutely.
stores
So
it.
photosynthesis.
Yes.
Photosynthesis.
Yes.
So plants take up the CO2. Yeah. So photosynthesis occurs. So they take up the carbon dioxide, and that same carbon dioxide, and they emit oxygen, right? So basically, they are breaking up carbon dioxide into carbon and oxygen, very simplistically speaking. But the reaction is actually very complex. But in a simple sense, the carbon actually becomes the body of the plant.
Yes.
Okay. So carbon goes into the body. It also goes for the energy requirements of the plant throughout the day. Okay. So whatever carbon dioxide you are generating after burning this same plant is the same carbon dioxide that the plant took from the atmosphere. So it is carbon neutral.
Yes.
So in the second point here, I'm talking about a few other things like other than environmental sustainability. So let's talk about, let's say, economic sustainability or social sustainability. So think from that perspective, maybe.
When it comes to economic, it is not feasible. It might not be feasible because there are different locations and transportation also comes into picture.
Yes,
Transportation of the
we
biomass.
discussed this, I think, yesterday or day before,
Yes.
right?
Yes, sir.
Sure. Yeah,
Yes.
that's absolutely true because because of the distributed nature of the biomass, it's incredibly complex to collect all the resources and economically basically collect all the resources, right?
Yes. Yes.
And how about
Because societal is where the farmers or the people might not be willing to uh, give away
yes,
their biomass.
yes, that is true, absolutely true. Let's come to the next one. So the big question about carbon neutrality. Now, see, I spoke about carbon dioxide. Think about the other greenhouse gases in this case.
CFC.
CFCs are not there in this case.
Oh,
CFCs
yeah,
are not
biomass
greenhouse gases
CFC.
also.
Yes, sir.
What about methane?
The methane,
Yes, methane. Where is methane produced?
Biogas. Biogas
is
plant.
plants
Even in
and
paddy fields.
Plants?
Paddy fields, sir. Paddy fields.
Yes, yes. I gave you this example a couple of days ago, right?
Yes.
So when you for paddy alone, you need flooding of the field completely. So it creates an anaerobic environment below the surface of the water. Okay. And
Yes.
so anaerobic digestion takes place. So if you go to a paddy field after a few days, you'll see some bubbles coming out from the water, right? If you have noticed it. So that is basically
Yes.
methane getting emitted. So this is not the case with any other crop where we don't flood the fields. Okay. So millets and all, it's perfectly fine. There are not much I mean, there's no emission of CH4 basically. There could be some soil carbon emissions. That's okay. Okay. And there is one more thing, which is when we apply fertilizers, right? Nitrogenous fertilizers like urea or ammonium sulfate and so on. What happens is that nitrogen in that fertilizer gets oxidized along with there is aerobic oxidation basically, right? Oxidized to nitrous oxide, N2O. And N2O is 300 times more potent than carbon dioxide. So CH4 is methane is about 25 times more potent than carbon dioxide in terms of global warming, and N2O is like 300 times more potent. So you need to make sure that you don't use so much fertilizers, but then this happens even using farmyard manure because farmyard manure also has nitrogen, and nitrogen is the requirement for the crop. So you can't really help it. Okay. And
That is why there is crop rotation used, right? Like where there are nitrogen forming bacteria in
yeah, no,
particular
it's
plants
not
like legumes.
nitrogen forming bacteria. There are
Nitrogen,
nitrogen fixing crops.
yeah, fixing crops. Yes, correct, sir.
Nitrogen fixing crops like legumes, like lentils and all.
Legumes.
Your tur dal, all of these dal varieties, right? They're all
Peas.
nitrogen fixing. So what happens when you for one cycle, if you plant this, they fix the nitrogen in the soil. So whatever nutrients are available in the soil will be taken up by the next plant. Okay. So they
Yes.
basically fix the nitrogen from the air into the soil. So that's how it happens. Okay. So you don't need
Yes.
much fertilizer for the next crop as well because there is enough nitrogen in the soil. Right. Okay, so
Yes.
the next one is, can biomass in its modern avatar successfully penetrate and enhance the livelihood of rural populace? So you think in terms of the Energy Plus
What is
initiative,
the modern avatar here, sir?
so what is the traditional avatar of biomass? Can you tell me?
Firewood, or
Yes.
like in cooking place.
Exactly. So now
Yes.
think modern.
Like in order to have a connection or energy, they can exchange it for biomass.
Exchange it for biomass as in like
Instead of paying the particular, what is that, a monthly bill for your
okay,
energy
okay,
consumed,
yes.
they can replace. They can you have give
That is
plastic and have food. That's
that is
simple.
similar to very similar to what I mean the traditional use, right?
Okay.
They'll need a lot of like complicated machines like bioreactors or something.
Yeah. So you mean to say biodigesters? Right?
Yeah.
So what does a biodigester produce?
Biogas.
Biogas. Yeah. So biogas is basically methane and carbon dioxide. Okay. Which can be used. I mean, we are not just emitting it to the atmosphere. Then it will be a problem, but we are using that. So that can be used for cooking. Either that or it can be used for generating electricity or whatever it is. So that is one thing. Another thing is, like I said about the modern cook stoves that do not pollute as much, they require all these briquettes. So you have all these rice straw and everything. You briquette it. I mean, you make pellets or briquettes of. Do you know what pellets or briquettes are? You're just compacting it. That's it, basically, into a certain shape. Okay, and you can use that in your stove. So that's another way this can happen. But in terms of Energy Plus initiative, where there could be some productive use of this energy, I think the only thing I can think of is when you produce some electricity or something like that from that biomass, okay, either through biogas or through gasification or whatever it is, and then use that to run some industry or something like that, right? Or some manufacturing from your own house or something like that. So that's what I can think of. And how economically feasible will a transition to a bio-based economy be? So that I think we discussed about the widespread, the distributed nature of the biomass itself, how it is going to be incredibly hard, and there should be very targeted policies that will help. Okay.
Sir, something very similar to what was done in your locality, you said, right? Like composting.
Yeah, composting is different. Composting is just
Yes,
if you're
like very
using the
similar to
waste.
composting, a biogas plant for a locality where they can.
Yeah, but you know the issue with the biogas plants is wherever there is a community-based project, especially in our rural communities, they never work because there is a lot of internal politics involved. Okay, and you need resources from everyone, right? So especially for
Yes.
biodigesters and stuff, you need biomass from everyone. It's not provided by the government or something like that. So people are not willing to do that, especially when it's a community-based thing. So it's more like, okay, why should I provide something of mine to someone else? It's that kind of a mindset.
Yes, sir.
And that's the issue. And that's what we need to change, right? We cannot change the mindset, but then we can change the model in which we are operating. So instead of it being a community-based biogas plant or something, you can have individual biogas plants where, okay, if you have how much ever biomass you have, you use it to run your plant. That's it. If you don't have enough
Yes.
biomass, you buy it from someone else, you know. So that is the
Yes.
only way it will work. You know. So we'll come to the question and answers, but before that, any doubts or any questions that you have for me?
Sir, about the poll.
Yeah. Once we are done with the questions, I'll do the poll. Okay.
Okay, sir.
I'll do the poll once we're done with the questions, and Yeah. Any other doubt?
No, sir.
Okay. So the questions. So what does the 8.5 in RCP 8.5 stand for?
Radiative forcing.
Yeah. What is radiative forcing?
The watt per meter square of carbon of heat absorbed.
Yeah. So basically, it's the heat trapped by the gases in the
Heat
atmosphere.
Yes.
How much heat is
Yes.
trapped by the gases? That is radiative forcing. Right. Next.
Yes.
Main goal of the Energy Plus program is?
So option D.
Why is it so?
Because when it comes to energy poverty, everyone should have access
Yeah.
in order to improve their style of living. Like, for example, you said about cooking. They
Yeah.
have to transition from their olden practices where it used to cause a lot of health issues to the modern ones.
Yes, absolutely. So it's basic energy services plus productive, something that empowers them, right?
Yes. Yes.
So, so with the advent of mobile phones and internet, I think a lot of people are actually using energy for productive uses. Like one good example is, have you seen this YouTube channel called Village Cooking Channel?
Yes.
Right? It's from
Yes.
Tamil Nadu. So they're just cooking in their backdrop of their village, and then they are using YouTube to popularize themselves, and they're earning also, right?
Yes, sir.
So that is a good example of this Energy Plus, as in energy for empowerment, economic development, right? So yeah. Next, what are the benefits of switching to modern cooking stoves from the traditional firewood stoves?
All of the above.
Yes. Right. So why is it so? I mean,
Yes, sir. The
first two
traditional
are
firewood.
yeah.
Traditional firewood has a lot of problems, like and closed areas, an improper combustion leading to carbon monoxide and different types of particulate matter,
Right.
and the heat transfer was inefficient, as you said. Uh, a lot of energy was being wasted.
Yeah. Because it is
And
open, out in the open, and a lot of heat, gets transmitted to the surroundings rather than to the cook stove itself.
yes.
Right.
Continue.
And point
Okay.
C.
Point C is like if you have a modern cooking stove, you will have a proper. Um, if your LPG gets empty, you just refill it. Just go to
Yeah.
the shop and they'll refill it. Then in case of firewood, if it's a rainy season, it will get wet and you won't be able to cook anything. And even if
Yeah.
you cook with that, it will cause more problems.
Yeah. So now in the modern stove case, you can just store the briquettes or the pellets or whatever it is, right? So you'll have
Yes.
the biomass pellets. You can just store them in a dry place, and you can keep using them whenever required,
Yes. Yes.
right? Then, okay, categorize the following as per the levels of energy use. First is electricity consumption at a local clinic, home lighting, and electricity consumption in a small scale factory.
A.
Why?
Is it? Because the electricity consumption at local clinic is outside your home, so that's social, and home
Right.
lighting is a basic thing, and the small scale factory is to create more jobs, so it's to be productive.
Yes, absolutely. Next, what is the purpose of normalization? This we have already gone through.
It's D, sir.
Yes, absolutely. So to standardize the indicators at different units for easy comparison and aggregation. So, right. So which among the following are social indicators of the electricity system?
So option D.
Why?
Because people will want a continuous supply of electricity, and they want to know,
Yes.
they want a reliable source of electricity, because they
Yes.
might be doing something important with using
Yeah.
electricity that way.
Yeah. And what are the other three dimensions? Can you just quickly tell me? First, second, and third.
First one is environmental
Right.
transmission, and second one is economic.
Right.
Sulfur dioxide emission per unit, and C is environmental.
Yes. Absolutely.
Yes. Yes.
Okay. Next, the lack of energy access to reliable energy supply is called.
It's called energy poverty, sir.
Yeah. Then, which of the following are energy service companies?
All of the
Option
above.
C.
So
Option C.
I got two different answers. Can you justify? I mean, whoever said C and whoever said all of the above. Can you please justify it?
Yes, sir.
Yeah. So please justify your answer.
Yeah, biogas plants, I mean, you can create renewable energy. And
Yes.
for wind turbine blades, for example, for like windmills, it will
Yeah.
create like energy and electricity distribution. You can supply electricity. So it's
Yes.
all.
True. That's what it is. So all of these three are energy service companies, basically. In some way or the other, they are furthering the cause of energy, basically energy plus or whatever it is. Right. Okay. So that's it for today. Okay. So let me quickly include the poll here. Okay. And so I'll be giving two polls. So in case someone's missing out, we'll see. Okay, if someone's missing out, what to do, we'll just check.